Other than the frame, which is used for compression, the equipment consists of the cell, which is the important part of this entire setup. It has two parts. The upper part, which is shown here, it's made of usually made of perspex, transparent perspex cell, unless it's usually also filled with water for pressurizing the chamber, but there is no stopping you from using oil instead of water. It's the lower part which I need to spend more time on today. A pedestal on which you keep the sample, which is encased by a rubber membrane, and you have a top cap as well as a porous stone at the bottom of the sample and top of the sample. So see that there are certain openings. Now in this figure there are 1, 2, 3 openings within the sample. In the cell you can have more than 3. So 3, in a sense, 3 is a minimum which any standard cell would have. So if you look at this carefully, one of the opening, the outer one, is shown to be connected to the water supply system. So I can have water which fills the chamber through this, and once the chamber gets filled with water, the same valve or the same inlet I use to pressurize the water. It's in fact used to connect the top of the sample. So I can have, if this was my sample, I can have a tubing which goes right through the, so I need that tubing can be connected to this outlet. So if I try to, right, the third one is right below the sample. So over here I have a single tube. Some cells have 2 independent tubes, 2 separate tubes. Now we have the tube which is connected to the pressure gauge. I can also bypass the pressure gauge, have a T section, so that I can also use it for drainage control. Okay. Now this certain things which have to be explained. I think I'll show it to you on the triaxial cell, the same triaxial cell, to get a feel of all the things which we have used. So I'm going to open up the 3 over here. Okay. So I've separated the 2 cell. The upper half is the perspex transparent cylinder. Like I said, if you are using, you can use water to fill the cell, or even oil. For high pressure test, this perspex is replaced by stainless steel containers. So for rock testing, you would have a cell with much higher pressure capacity. Usually these cells are of about 2000 kPa. So this is 1700 kPa. That's the pressure at which the material will start to deform, will show some plasticity. But we don't exceed beyond 50% of this value. So that's about 1000 kPa or so. So the cell top has the loading ramp. So that you have a stand to hold the gauge, dial gauge. So your vertical deformation is measured by when the cell moves up and down by the compression frame. This frame also helps to hold the piston. So in case you're preparing a sample, you're putting this thing over the sample, you don't want the piston to fall down and crush during your sample, when you prepare your sample. So that's quite handy too. Now the base it's important to understand what the base is. You would normally find an O-ring around the base. I hope you can see this. This O-ring is to seal the top half of the cell to the lower half. This O-ring, black color, is not called because of the letter O which they make. So you see this letter, it's because if I cut a cross section of this ring anywhere, it'll be a circle, it'll be letter O. So that's why it's called an O-ring. So you have an O-ring, a centrally located pedestal over which I can place my sample. Now, I don't have a dummy sample here in my office, but just visualize that if there is a sample, these two holes which are right underneath the sample would be connected to the outside world using this opening. So this hole is connected to this particular opening. The other hole is connected to the opening which is right opposite to this thing over here. There are three more openings. Now, one, two, three. Okay, so each one of these openings has a link to the outside world. So it's directly, the closest, opening is the one which, our guess is it should be related to that. But in the older versions of cell, you could, in fact, if I used twist it around, I could see the connection between the openings and the valves or the outside world. So, but now it's all covered up. So the only thing is we see which one is the nearest port which links this thing to outside. We used to have previously valves, proprietary called Klinger valves, but now I think all of them which I see they make when I open or close. So the cross section of this is always a circular hole. So the diameter reduces the hole. It's always a circle so that you don't. In the sketch which was shown to you from VS Code, I think there were just three openings. So one at the center, but right now we have a comfortable two, and I guess there were two outside. Now I'll just but now we have three. Doesn't matter, but we what the cell is. But for this particular case, let me explain what each and every opening is about. Okay, I'll just put it towards this camera. So this should be the one in which I can have a transducer cable coming in. So I can plug in a a cable from a data logger, plug it in. The cable can come in, and I can put some transducer over the soil sample. So it's quite comfortable to do that. The other two openings are there, which are just to fill, which are linked to the chamber that is outside the soil. So I can use any one of them, okay, any one of them to fill the chamber or fill the cell with water, right? So if I choose this one, I can dedicate this to fill this with water. I can also use the other one. It's no harm. But the other one, in this case, if I choose the other one, I can hook this hole using a tubing to the top of the sample. So if I connect top of the sample to this hole, I can have two-way drainage. All right. So the bottom is already hole. One of these holes is linked to the outside world here and there. So I can use this hole for drainage at the bottom, as well as the tubing which comes from the top. I can hook it up over here for drainage at the top. So I can induce two-way drainage. It's quite helpful for low permeable soil when you want to get this consolidation done in a hurried way. It's also useful to saturate the sample, as we will see in the next few steps. Okay, that's the hole which connects to the outside world. All right, this has bottom drainage. The other hole obviously is useful. So the other hole is connected right over here. So it's useful to if I want to measure the pore water pressure as well. Okay, so I can connect a gauge over here. Now please mind it, I cannot measure the pore water pressure as well as open the drainage together. I open this to the outside world, to the known pressure, and at the same time I can't measure the pore water pressure within the sample.